Hi friends, in this video we are going to learn how to delete a node from a linked list. So this is the code to implement this program. So we have the function delete node to perform this task. So here we have a linked list of nodes with values 10, 20 and 30 where 10 is the head. First of all, what you want to do is find the key in the linked list and delete it. So we have two cases here, if the head node is the key to be deleted and if it is not. So here we are going to delete 10 from the linked list. So we call the function delete node and first we check if data in head node equal to key. So here we have 10 which is same as the key. So head will be stored to another temporary variable temp. Now we have head equal to head next. So what do we have at head next is 2024 and head will now point to the node at 2024 and that becomes the new head which will remove the node from the linked list and we can free temp to free the space. Now let us take the same example again but this time the key to be deleted is 20. So first of all we check if key equal to head but it is not. So we go to the else part. So here first another variable current will point to the head node. Now we traverse the linked list using the while loop. So while loop will execute until we reach the end of the linked list or last node where node next will be null. Here we have current next equal to 2024 which is not equal to null. So we check if current next data equal to key. So in the first iteration we have current equal to head. So current next will be node 2 and its data equal to 20 which is same as the key. So the if condition is true. So back up that node to temporary variable temp. Now make current as current next. Simply make current point to the second next node. Here in this case node 1 will have to point to the third node. Now the node is removed from the linked list and we can free temp to free up the space. And this is the resultant linked list after deletion and now we can break out of the loop. Now let us take the same linked list again and try and delete node 30. So first we check if head equal to key but it is not. 10 is not equal to 30 so we go to the else part and make current point to the head. And we traverse the linked list until we reach the last node using the while loop. And we have current next equal to 2024 which is not equal to null. So we check if second node is having key 30 but it is not. So if condition failed, so we go to the else part and current equal to current next. So current will point to the next node and repeat. Current next equal to 3024 which is not equal to null, so enter the loop. And check if current next data equal to key and current next equal to 3024 and its data equal to 30 which is the key. So if condition is true here, so back up the node at 3024 to temp. And current next is what? Null. So that will be stored in current next. So it will no longer point to 3024 but there is only null in the next part. So it is removed from the linked list and we can free temp to free the space and we can break out of the loop. Now let us relate this with the train scenario. We have engine followed by other coaches, just like head followed by other nodes in a linked list. So first case is delete A which is the engine, so remove the engine and make B the new engine. Now let us delete C. So first we need to find C. So engine is not C, first coach is also not C and yes, second coach is C. So we found C, now remove C and make B directly connected to D. So that is how it works. Now let us discuss about the time complexity of this operation. Actually the time complexity of deleting the node is order of 1 but it is the time taken to find the node first. So the best case time complexity will be when the node to be deleted is the head of the linked list. So it will be order of 1 and the worst case will be when the node to be deleted is the last node of the linked list. Then you need to traverse the whole linked list to find it and then delete it. So if you have n nodes, then the worst case time complexity is order of n.